All right, so this first part of 3-2 is going to connect really closely back with 2-8 that we just did a little while ago. We solve systems of linear equations and inequalities, just like one of the linear inequalities. So this one's a system, meaning we're going to put two inequalities on the same graph and then see where they intersect. All right, so systems of inequalities, the step-by-step is pretty straightforward. So step one is you graph each inequality. Meaning just like 2-8, you graph the boundary line, dotted or solid, figure out where you're going to shade there. I usually color code, and you'll see. And then step two, identify the overlapping region. This is your solution. So the overlapping region, if the two regions overlap each other, it means it's a solution of both of the inequalities. And if it's a solution of both, that means it's a solution of the system. So that's how you find your solution for the system of inequalities. Okay, so example one. This first one, we're just going to do a quick sketch of both of those graphs. So remember, we've got different ways that we graph, and these ones are in slope-intercept form. So for slope-intercept, what we do, so the boundary line for this first one is y equals 2x minus 3. It's got a greater than or equal to, so we're going to make it a solid line. So what we're going to do is we're going to start with our y-intercept of -3, and then we've got a slope of +2. So that's how we're going to graph this line. So we're going to go down 3 units. That's my y-intercept. And then I can use a slope of 2, meaning from here I can go up 2 units and then over to the right one, just to get an idea of what my slope looks like. Okay, you only need 2 lines to plot a point, and we know it's going to be a solid line. So connect the dots there. Looks like this. Okay, then what we do is we are going to test 0, 0. Remember, as long as it's not on the line, we can test it. So is 0 greater than or equal to 0 minus 3? Question mark. So is 0 greater than or equal to -3? And yes, it is. It's definitely a true statement. And so if it's true, what that means is I shade the region that contains 0, 0. So I'm going to give this just a quick shade in one color. I have selected turquoise blue for this one. So it's kind of hard to see, but here we go. Okay, so that's that first region. Next, we're going to graph the second boundary. So the next boundary line is y equals -x plus 2. This one's strictly a less than, so it's going to be a dashed line. My y-intercept, I'm in y equals mx plus b, so I'm going to graph using the y-intercept and the slope. My y-intercept is +2, my slope is -1. So let's start with that. So I'm going to go up 2 units, that's my y-intercept, and then my slope is -1, so I'm going to go down 1 and to the right 1 to plot a second point. So again, all you need is 2 points to plot a line. This one is dashed, so be careful with that. This is one of the easiest things to forget about. So if you forget about it on a mastery check or a test, just make me a little note and say like, oops, this should be dashed. Okay, so now our test, 0, 0 is again not on the line, so we can plug that in. So is 0 less than -0 plus 2? Okay, so 0 is in fact less than 2, so that is another true statement, which means I shade the part that has 0, 0. So I shade kind of like down and to the left of this one. Okay, so this, I've got a nice red-violet shading going on with this one. And so that's step one, as we graphed each one individually. Identify the overlapping region. This is the solution. So that is going to be kind of this region right here that's shaded both in turquoise blue and red-violet. So I'm going to shade this region nice and dark. I want you guys to make sure you're doing that. Even if you're just using pencil, I want you to identify this region as the darkest region. Give me some indication that it is the solution set. Okay, so you need to identify that separately. So for me, I made it all purple, went with my preschool color combinations. So that's what your solution should look like. That would be your final answer. All of this is kind of work that you should do, just little scratch work on the side, but this right here is really your answer. Okay, next one. This one right here, we've got also similar equations. These ones are in slope-intercept form too. So for the first one, my boundary line is y equals -3/4 x plus 1. Okay, so my y-intercept is 1 and my slope is -3/4. This one, since I have the or equal to, it's going to be a solid line. So let's start this off. Okay, y-axis, x-axis. So my y-intercept is 1, so I'm going to plot my first point there, and then my slope is -3/4. So from there, I can go down 3 units, 1, 2, 3, and then over to the right 4. So 1, 2, 3. So again, rise over run. I rise, technically, -3 units, and then run 4 units. And there would be a second point right there. So 2 points for a line. This is going to be a solid line, so I connect the dots. Looks like that. And then I test the origin since it's not on my line. So plug it right in here. Is 0 greater than or equal to, and we know this is just going to turn into a 0. So is it greater than or equal to 1? No, it is not. That is a false statement, which means I shade away from the 0, 0. So this is false, which means I shade in the other direction. So I'm going to shade everything up here. Okay, so that's my first one. Second inequality, my boundary line is y equals -3/4 x minus 2. My y-intercept is -2, and then my slope is -3/4. So notice this slope, same as this slope, which means these lines are going to be parallel. So let's see how that plays into the solution. It's going to be another solid line because I have the or equal to. And so let's graph that. So my y-intercept is a -2, so I start there. And then for my slope, I rise down 3 units and then run for 4. So I'm going to have another point right here. It's a solid line, so I'm just going to connect those dots. Oops, missed that one, sorry. Okay, and then test the origin. So is 0 less than or equal to 0 minus 2? 0 less than -2, no, that is false, which means, again, I shade away from the origin. So the origin's up here, that means I shade on the opposite side. So I'm going to shade down here. Okay, so step 1 takes a little longer than step 2. Step 2, as we wrote up here, is just to identify the overlapping region. Now, these lines are parallel. I shaded above this one and below this one, which means you're going to have this strip of white in between, keeping these two regions from ever intersecting. So the overall answer to this one would actually be no solution. Remember, that's our symbol for no solution. They never overlap each other, which means that you're not going to have any region that's common to both of these inequalities. So that would be no solution. Okay, we're going to look at one more example real quick. That'll be part of this one. We've got a story problem that we're going to set up. Mr. and Mrs. Rodriguez are driving across the country with their 2 children. They plan on driving a maximum of 10 hours each day. Mr. Rodriguez wants to drive at least 4 hours, but no more than 8 hours. And then Mrs. Rodriguez can drive between 2 and 5 hours. Okay, so let's say Mr. Rodriguez, his hours will be X. Mrs. Rodriguez, her hours will be Y. So we're going to set up the system of equalities and then graph it. So they plan on driving a maximum of 10 hours each day. So what he drives plus what she drives has to be less than or equal to 10. 10 is the max. So whatever they drive has to be less than the max. Okay, Mr. Rodriguez wants to drive at least 4 hours a day, but no more than 8 hours a day. So that's one of those sandwich inequalities. So Mr. Rodriguez wants to drive at least 4 hours per day, but no more than 8 hours per day. Gets sandwiched in between. And then Mrs. Rodriguez between 2 and 5. So that's another sandwich inequality. So at least 2, but less than 5. Okay, so that's our system of inequalities. We're going to graph it. So now this one, this first one right here, we have an example of one that's in standard form. So remember, when you're in standard form, you're going to plot using the X and Y intercepts. Okay, so for this one, your X-intercepts, remember you plug in 0 for y, so when we plug in 0 for y, we just end up with 10. To find the Y-intercept, opposite, you just plug in 0 for x, and so we come up with 10 for that as well. So let's plot this one. So we're going to go by 2. 2, 4, 6, 8, 10. Remember, if you scale, you have to write down what your scale is. If there's nothing written on these little pegs right here, I would assume that they're 1. Okay, and then Y-intercept, 2, 4, 6, 8, 10. Okay, so Y-intercept, X-intercept. This is a less than or equal to, so I'm going to connect the dots with a solid line. However, X is the number of hours that Mr. Rodriguez drives. He can't drive a negative number of hours. And Mrs. Rodriguez also can't drive a negative number of hours. So when I connect these, I'm actually going to connect them using only a segment. Not a line, not array, just a segment. Because negative y values and negative x values don't make sense in the context of the problem here. Okay, these aren't just like normal equations, they're equations that are connected to a story problem. So going into the negative regions over here makes no sense. You can't drive negative hours. Okay, so this one, x has to be between 4 and 8. So here's an x value of 4, and then 6, 8. These are going to be vertical lines. If all you have is x and no y, the x values are the only ones that affect your equation. So these are both less than or equal to. So these are going to be solid lines. Okay, so this forces the x value to stay between 4 and 8. So it's just going to be anything in here, and I forgot to start shading. So this, I'll do this one first since I'm already on it. So Mr. Rodriguez will drive somewhere between 4 and 8 hours, so somewhere in that region. Let's go back to this one, I apologize. So this one, if we test the origin, is 0 plus 0 less than or equal to 10, and that is definitely true. Okay, so we're going to shade under, but remember, the context of the problem keeps us just in this first quadrant where all the values are positive, because we can only talk about positive hours. Okay, so that's what we've got so far, and we're going to deal with this one last. So a y value of 2 is right here. A y value of 5 is right here between the 4 and 6. They're both going to be solid lines, and so let's extend out. So this marks what Mrs. Rodriguez will drive. So she is only going to drive between 2 hours and 5 hours, and that's just marking up the y-axis. So let's shade in what she's going to drive. Okay, so we've got 3 different regions here. We're looking for the overlap between them, and that will tell when they can all, or like what could actually happen in the context. So what could actually happen in the context is this region in here. I'm going to darken this up. I'll try my best anyway. So we can see this region, it's almost a triangle. It kind of gets chopped off at the 2 sides. So this guarantees that Mr. Rodriguez is in his driving comfort zone here. So is Mrs. Rodriguez, but they're marked here on the top saying that in combination, they're not going to drive any more than 10 hours. All right, so we'll finish up the next video with this last little problem. So this second part of 3-2 should be pretty short. We've just got one little problem here, kind of one final aspect to add in, and this is actually going to help us transition into section 3-3, which is our next one. So what we're doing is kind of the same thing that we were doing for the first part. We're going to graph this system of inequalities, but what's going to happen is these are actually going to close off and form a triangle, and we're going to find the vertices, which are like the 3 endpoints of the triangle. So that's what we're looking at here. I put graph paper down. It's super, super, super important that you guys are using graph paper or a grid or something, because these need to be super accurate. You can't kind of guess, because you need to know exactly where these are intersecting each other. So I have graph paper. Just ask if you need it. So we're going to take a look at this first one. So equation number 1, so let's label these 1, 2, and 3. So, or I'm sorry, inequality number 1, I guess, is in standard form. So we're going to find X-intercept and Y-intercept. So for our X-intercept, what you do, remember, is you just cover up the Y. So we cover up the y, divide both sides by 2, and our x-intercept would be -1/2. So we can start with that. And then our y-intercepts, if we cover up the x, we divide both sides by a -1, so we get positive 1 for our y-intercepts. Okay, so let's start with this one. So we've got a y-intercept of negative 1/2, so we're going to plot that. And then, x-intercept of negative 1/2 and a y-intercept of 1. So you can see here that we're going up 1 unit and over half a unit. So we could keep going up 1 over a half, up 1 over a half, or we can scale it and we can start going up 2 over 1. So this is super, super important that you're actually marking every single value that you can. So you can also go down 2 and then to the left 1. So from here, this would take you here, down 2 to the left 1, down 2 to the left 1. Again, super, super important because when you're looking for the intersection points, you need to know exactly where they are. So this would be a solid line. We're going through all these points. Ignore, there was a spare point that didn't belong there. Just do your best to ignore it. And then we are going to do our test. We can test the origin because it's not on our line. So plug in 0, the whole left side becomes 0. So is 0 less than or equal to negative 1? Yes, it is. That's a true statement. So we're going to start by shading the region that does contain 0, 0. So that would be everything kind of to the right and below this line. So everything over here. All right, I know that's hard to see, but our final region will be like the overlap, so I'm going to get that really heavy. So number 2, we've got x plus y is less than or equal to 4. And so we're going to do the x and y intercepts for this one too. So x-intercepts, we just plug in 0 for y, so we end up with 4 for the x-intercepts. And then for the y-intercepts, plug in 0 for x, so our y-intercept is also 4. So we can plot 4 on the x-axis, we can plot 4 on the y-axis. This is a less than or equal, so we know it's going to be solid. And then if you look here, going down 4 to the right 4 is the same as going down 1 over 1, so you can mark down 1 over 1 all the way through. Again, it's super important that you're being really, really accurate because we need to know exactly where all these lines are intersecting each other. So solid line, it goes through each corner right here. Okay, and then we're going to do a test. We can test 0, 0, so plug in and the whole left-hand side becomes 0. Is 0 less than or equal to 4? Yes, it is. So I'm going to shade underneath this whole region right here. Oops, broken crayon. All right, so we get that whole part. And then I'm going to do my third one. So this, I've got x plus 4y is greater than or equal to 4. So starting with my x-intercept, I plug in 0 for y, so I get 4. And for my y-intercept, I plug in 0 for x. So if I divide both sides by 4, I get 1. So same x-intercept right here, and the y-intercept is 1. I have the or equal to, so I know it's going to be a solid line. My slope here, I go down 1 to the right 4, so I can carry that on. So down 1 to the right 4 would take me like right there. I can also reverse it and go up 1 to the left 4, up 1 to the left 4. So connect those dots. Super, super important to be accurate because now I can see exactly where all the intersection happens. So I can test this one. Test 0, 0. Let's see what happens. 0 on the left, is that greater than or equal to 4? This time that is false. So I shade the region opposite of where the origin is. So instead of shading towards the origin, I'm going to shade away from the origin. That'll end up being over here. So my overlap between those three regions, like we mentioned, ends up being the triangle. And so we get this triangle in the middle. That's our overlap between all three of these regions. And the triangle is closed off on all sides. Like it doesn't go forever in any direction. So what we're looking for is the vertices. And that's these 3 points right here that mark the edge of the triangle. Okay, so let's start with this one. We'll label it. So this is right on the x-axis. This is the point 4, 0, because we didn't go up or down. So that's one of our points. This one right here, this is over 1 up 3. So the x value is 1. The y value is 3. That's another vertex, I'm sorry. This right here, that's right on the y-axis. This is the point 0, 1. We just went up 1 unit from the origin. So there are 3 points. We've got one of the vertex, another vertex, another vertex. So we've got 3 vertices there on our triangle.